Paramita ma'am, you can start.
Okay, ma'am. So now we are going to start our technical session 1. So for this session, we have our honorable speaker, Professor Amlan Chakrabarti with us. Sir, we are honored to have you as our expert. Now, may I take the pleasure to introduce our today's speaker, Professor Amlan Chakrabarti, to all the participants. Dr. Amlan Chakrabarti is a full-time professor in the A.K.Choudhury School of Information Technology at the University of Calcutta and the former Dean Faculty of Engineering and Technology of this university. He is an M.Tech from University of Calcutta and did his doctoral research at Indian Statistical Institute, Kolkata. He was a postdoctoral fellow at the School of Engineering, Princeton University, USA, during 2011 to 2012. He has almost 20 years of experience in engineering education and research. He is the recipient of prestigious DST Boyscast Fellowship Award in Engineering Science in the year of 2011, Indian National Science Academy Visiting Faculty Fellowship in the year of 2014, JSPS Invitation Research Award in the year of 2016 from Japan, and many more awards. He has also served in various capacities in various higher education organizations, both at national and international level. He has received multiple project grants in the areas of security in cyber physical systems, IoT, embedded system design, VLSI design, quantum computing, computer vision, and data science from various national and international agencies. He has contributed immensely in the development of intelligent algorithms and systems to support real-time applications, cybersecurity, quantum computing, healthcare, environment, and water quality, etc. He was the principal investigator of the Center of Excellence in System Biology and Biomedical Engineering, University of Calcutta, funded by MHRD under TechU3 funding during 2013 to 2017. Till date, he has graduated 16 PhD students. He has published around 180 plus research papers in referred journals and conferences. He is a senior member of IEEE and ACM, IEEE Computer Society, Distinguished Visitor, Distinguished Speaker of ACM, Vice Chair of IEEE CEDA India Chapter, Vice President of Society of Data Science, and Life Member of CSI India. He is the series editor of Springer Transactions on Computer Systems and Networks, associate editor of Elsevier Journal of Computers and Electrical Engineering, and guest editor of Springer Journal of Applied Science. His area of interest are machine learning, computer vision, cyber physical systems, quantum computing, and VLSI CAD. Sir, on behalf of Department of Applied Electronics and Instrumentation Engineering, Guru Nanak Institute of Technology, we welcome you in this STTP program. Sir, we are very much honored to have you as a resource person in our STTP program. Now, I would request our coordinator, ma'am, to facilitate our honorable speaker with the virtual flower bouquet. Ma'am, please give me 1 minute time to share my screen.
Sir, good morning and welcome.
Yeah, thank you. Thank you for this wonderful memento. Thank you.
Thank you, sir. Okay, sir, I made you the co-host. You can share your screen and you can start your session.
Thanks, Paramita, for this brief introduction, and thanks to the departmental head, Madam Papita, for inviting me once again to speak to all of you. And thanks to the principal of the college for patronizing this wonderful program. So I hope that some of you have already know me, and you have listened to my lecture in the phase 1, and some of you are joining new in this particular phase. So what I lectured in the phase 1, I that means think that this is already known to all of you. So in this particular phase, in this particular lecture, I will be speaking something which is more onto applications, and we know that the applications for the society is of utmost importance, okay, at present day. So my today's lecture will focus upon the way we can use the Internet of Things for the various societal activities and for the various activities which are of utmost importance for the human society. So I will touch upon some of them. Obviously, you know that there can be many things we can plan, and a lot of many applications are already there. But I will try to motivate you with some of the applications and some of the theoretical understanding, okay, in designing those applications and how to implement them in systems, right? So I hope that you will enjoy this session. And again, that if you have any questions, what I will do, I will try to give some pause in between my lectures. Maybe if I cross 10 to 12 slides, I will give a pause and I will get back to all of you. If you have any questions, you can put it into the chat box, or you can ask me when I will be asking you during the pause of my session. Okay, so let me start my presentation. So I hope my presentation is visible to all of you and I'm audible to all of you, right?
Yes, sir.
Okay. So the title of my today's lecture is IoT Technologies for Sustainable Society. And I will try to motivate you in this particular direction, both on the side of technology, as well as in the interesting applications that we can develop using the IoT technologies for the various societal needs. So I think that we all know what is IoT, and that is a very simple way the internet society defined, right? It is the Internet of Things, or IoT is something that where the devices gets connected, or everyday items get connected with the internet, and this helps us to generate new data, to generate a sort of sensed ambience in the environment, right? And thus helps to do our job in a better way. That means it makes our life better, right? And also, okay, in some cases it gives us enjoyment, okay? So there are various application scenarios by which the IoT footprints covers the present human activities, right? And the most important part of this is that this particular applications, or this particular domain of applications, are being guided or are being driven by devices which are connected to internet, right? And that's what is Internet of Things. So if you look into the way we are trying to move across, okay? So IoT, actually the concept that we connect to internet, right, and to communicate our data to the internet, right? We started in something 1990, right? We had just started the internet space in 1990, where we could connect with anyone in any part of the world, and we could push the data, okay, from here to there or from there to here. The next paradigm shift was that the data was influencing our life, right? We slowly got connected with the social perspective of internet. Okay, the early internet was basically about sending or receiving data, which is specially meant for our official job, right? Or just communicating messages with my friends or my family members. But the next phase of internet came with different type of aspects where we got socially connected. Different types of social networking sites developed, okay? Facebook, LinkedIn, right? And others, not many others, Instagram. So they actually tried to connect the society in a greater way. And it actually generated a different type of personal world, right? Okay, in the cyberspace. Now, in 2000, in 10 or 12 years ago, or 2000, around 2010, what we started that, okay, let's try to control something through internet. Okay, let's try to control something through internet. Let's try to generate data which is not generated by human actually. These are data generated by your devices, and they communicate with the internet and they do something without the human intervention. Okay, a sort of automation through internet. So people use the remote access type of stuff, right? And also people use the remote monitoring systems, which were basically autonomous and which were guided by internet, right? And slowly and steadily the devices got also plugged to these activities. Okay, and that's the era of Internet of Things. Now, as devices comes into existence, right, which are not directly controlled by human, which means that we are not switching on or switching off the button every time, and we are just making the devices on or off. But they are just distributed, okay, in our environment. Automatic traffic detection, okay, the cameras which are being posted in different traffic posts to find out that who are violating the traffic or not. It is not that we are actually telling the camera that, hey, you snap this, hey, you don't snap this. Okay, it is a sort of coordinated devices, okay, which actually makes the action, right? And then the next phase of thought process generated that, hey, these are the devices are doing the stuff, devices are doing the activity. So what will be the regulations and policy, right? The important question which raised, I think, one point of time, I think now it is settled. Okay, autonomous vehicle, we all know, right? What is autonomous vehicle? Autonomous vehicle is something which can move without a driver, a vehicle, a car which moves without a driver, right? And maneuvers in the traffic and starts from the source and reaches the destination. Now the big question is that this particular autonomous vehicle, okay, there's an accident which is caused by the autonomous vehicle. Who will be responsible for that accident? Because we know that whenever a manually driven vehicle, okay, collides with something, right? The police, the regulatory, the legal authority actually catches the driver, right? Or maybe going to the person who owns the car, right? And this way it goes on. Now, what happens when an autonomous car fails? Because when an autonomous car fails, there is no driver. Okay, you cannot just blame the owner also, because owner has purchased the car from somewhere, right? And full autonomous hardware and software has been built by that particular, or has been put into by that particular car company into the car. So there is no hand of the particular owner, right, in that particular accident. Now also you cannot blame the car company also, because the car company actually didn't develop that software or the hardware. They're dependent on third party. Okay, might be that it's just that it might happen that they didn't develop that. They have just taken it from third party. So whether they to blame because their fault has caused this particular issue. So this is a big question, because whenever you have something which is not guided by humans, right, and then if it fails, or if it does any sort of malicious activity, okay, where the responsibility will go, right, and how we control those so that doesn't happen in future. That's a very important thing, and that is the policy, okay, policy which is now being considered as one of the very important aspect as this IoT gets into our daily life. And this is very important in the context of my lecture, is that because what I will be talking today is basically having a deep impact on the society, right? So if you have a deep impact on the society means common people, right? It's a common environment. So if something is going fine, it's okay. But if something goes wrong, right, how to rectify it, okay, and how to assure that this will not go wrong, okay, again. So those are the issues which I will not close in this particular lecture today, but these are the issues I think which will be very important in actual applications of the IoT for society. So if we summarize the challenges in the present domain in the perspective of applications which helps the society, or the applications of Internet of Things in general, right? These are the issues, right? The interoperability and standards. Okay, I am connected to a couple of IEEE standards for IoT, right? And this actually, people thought about this IoT standards only for the past 4 or 5 years, though IoT existed much longer. Okay, the drive was that because the people thought that if you want to deploy applications to large scale, without standards, we cannot work upon, right? Standards are very much required, because if you want to work in large scale, right, you're meant to maintain, okay, a sort of rules and protocols, okay, so that you don't need to actually add everything at a very custom way. But it can be generalized in a very, okay, it can be generalized and it can be applied in many applications. So that's why the need of standards is very required, right? And another one is interoperability. Interoperability means that, okay, if I have a device and it is working with a communication protocol X, whether a device can work with another communication protocol also, right? Or we are developing a sort of framework, which framework has some sort of architecture which supports a sort of software and hardware architecture, right? So if I change the software and hardware architecture at the back end, whether my devices will still work. So those are the interoperability issues which are also required for the scalable applications, okay, of these particular devices. The other two important sectors which I didn't cover also in this particular lecture, maybe if I get some other opportunity, I will try to cover, which are security and privacy of this. And this is very important in the domain of IoT, okay, because IoTs are just like your devices which are generating data in oblivion, right? It is not that, okay, you have a full control that what data is generated and when the data is generated, right? They are just autonomous devices which can generate a lot of data, right, at different point of time. So there are two things: is that security means, I think, okay, so all of us know what security means. Security means confidentiality of my data. So let me try to help you a bit. Security means confidentiality of my data, okay? Confidentiality of my data. integrity, and denial of service. I'm not going into the, so this is one, this is two, this is third. There is also something called non-reputation, which I'm not trying to go into the IoT context. This is more when we have a real person-to-person message communication. Okay. So what is confidentiality? Confidentiality is that, okay, I have some communication secret, okay, by which my identity will be known, okay, to the others. And now, if this secret is being, if the secret is known, right, or the secret is being captured, okay, by a malicious intruder, right, that can behave as an imposter in my network, right? That will be an imposter in my network, and that will generate the data or generate the activities, right, in my name, right? And that's okay, and that will be catastrophic. Okay. For example, your authentication. That what is an authentication? Authentications are something that you try to, that is, suppose a device is authenticating itself in a network, but it means that the device has, there is some process, there is some key exchange process by which the device is recognized by the either by the fog or by the cloud, which is the back end of your IoT system. Now, if some way this authentication keys, okay, get known, okay, by any third party, okay, they can then put their own device and they can mask your device, which is very okay. And then you are trying to record the data of your room when you are at office, and you find that everything is fine, but actually, okay, that means there is some a very wrong incident is happening in your eye, okay, in your home, right? The temperature sensors, the humidity sensors, okay, the electrical sensors can go wrong and can cause the catastrophe to your, okay, in your house. But there can be other sensors who can just mask this, because they have broken the confidentiality of your devices. Second part is integrity, which means that you are changing the data, right? You can changing the data of your device. Okay, third party malicious access intruders are changing the data of your device, so you're not getting the actual value of your environment, right? And your actions are based on wrong values, right? And that can also be catastrophic. Okay, suppose the medical devices, medical IoTs, environmental IoTs, your home appliances, right? If the data is being tampered, right, that can lead to catastrophe. Denial of service means that you are trying to get a service. Your device is trying to get a response from your server. It is trying to fix your GPS coordinates, GPS location, but you're not getting that. So your car will be in no man's land, right? If it cannot connect with a GPS server, and your GPS server can be attacked, and there's a denial of service. So your entire travel may be very, that means you may reach to another different destination, or you may reach to a particular trap, right, where your enemy has taken you, right, and has put it into a trap where you actually go towards the enemy, and the enemy gets catch hold of it. Okay, so these are the scenarios which are very real, and there are a lot of real cases which has happened on each of these scenarios. The other part is privacy, right? I have talked about security. The other part is privacy. So privacy is another impression or another effect what we have in the data, right? So privacy means that you are authorized to use the data in one form, right? But you are using the data in another form, right? Okay, for example, you are, suppose your, okay, your blood, suppose your medical data. Okay, there are medical IoT which are implanted, and I will also discuss that people can take the information about the blood, okay, from those sensors, information about your body parameters from your sensors. So now these body parameters, the knowledge of the body parameters should be only used for your medical purpose. Okay, analyzing the medical condition of your body. If not, it will be a data privacy. Suppose I get the medical condition of your body, and instead of the doctor, I send it to a pharmacy company, and the pharmacy company comes to your house and knocks your door and tells that hey, I want to sell this drug because I know that you are having this problem. So this is what is breach of privacy, because your data, what you have sent, should go to the doctor so the doctor can take a proper action, right? Your medical data shouldn't go to a company, okay, which is selling drugs, because that will, like, if they use your medical data for selling the drugs, this is the breach of privacy, because your data was not meant for that. Your data was not meant for selling medicines to you. Your data was for the clinical advice to be given by the doctor. Okay. And regulatory, and those I have already discussed, that you need to have regulatory and those things. And then there is something which is there, that this is actually where societal development comes. So how IoT can enhance the life patterns of individuals? How can IoT influence the economy? How the IoT can increase the development? So what do you mean by development of a society? Development of a society means basically housing, health, right, and food and education. Okay, so housing, health, food, and education. These are the main four, and there are many others also. You can add to that. So how IoT can influence these activities of a human society, okay, and whether that can lead to the development of a society at a large. And we all know that IoT can very well play a role in each of these domains of human society. In this lecture, we will also see some of them. Okay, this is the famous 2017 9th June meeting, which was being attended by the scientists and the policymakers, right, in Geneva. Okay, and here the declaration of IoTs for sustainable development was taken. Right, you can get the reference. Okay, if you do the Google, you can get this reference. Whenever you see the sustainable development strategies for IoTs, right, you have to refer this particular meeting and the resolutions taken in this particular meeting. Some of the resolutions I have listed here, right, and they are pretty interesting to know what are these resolutions, so that you get motivated that what we are doing, okay, is a part of the activity which the entire world is looking forward to, right? And that's the way we scientists or technologists actually contribute in the society. So the first point was, it is a adoption of IoT technologies for benefit of humanity, environment, and sustainable development. So IoT will be a means of sustainable development. This was officially taken on record, right? And from that you will have, from that generated lot of activities okay, which actually branched out from this particular decision. Secondly, IoT will have a very great aspect in the different types of ICT, right? ICT applications to have a smarter rural and smarter city, like the concept of smart cities. Okay, it's concept of global e-village. Those things were taken into consideration, and people really tried to push them as the avenues for IoT development. Right, and obviously there is the promotion of the startups, and in the domain of IoT was one of the main push in this particular discussion. And obviously standards. That means whenever we scale up, okay, we require standards, right? And that was also a major direction which was taken from here, right? And obviously there is something more apart from the support of IoT. There are more deeper problems, right? The problem of hunger, the problem of water supply, the problem of food security, whether they can be well addressed. So the IoT deep exploration was being taken from here onwards, right? And obviously the climate, which is another part of the society, we cannot disassociate, okay, our human society with the climate and environment, right? And that's why the mitigation and climate change mitigation, how to protect your environment, how to know the present status of your environment, how to know that whether the climate is getting extreme, or it is within the limits, and what are the good effects and what are the bad effects on the climate. Those all being studied with different types of data collected by different types of sensors, right? And another important part is biodiversity, right? That is whether we have the biopopulation of the world which can be preserved. We know that there are scientific statements, right? I am not a very expert in biology, but what I read from the papers or from the scientific statements is that one of the reasons of this virus attack, or the spread of the virus, okay, in the human, is biodiversity. It means that the other type of organisms, bioorganisms, which survived earlier, right, are now extinct, present. So the viruses which used to have them as a habitat, they are now trying to find new habitat for them. And that's why they are coming closer to our human society and affecting that. This is I think a beautiful research has been done and declared very recently by a group of scientists from India, where they have shown that the effect of biodiversity is one of the cause why the viruses are mutating and they're coming closer to affecting our human population. So to maintain the biodiversity, okay, to maintain the ecological balance in the earth, air, and water, okay, which means biodiversity, that is important aspect of IoT also. So you see that what I try to tell here is that there are a lot of areas where IoT applications are being planned, and people have started working. There are a lot of groups across the world which are taking each of these or multiple of these areas and are doing fantastic work. Okay, and that actually gives us the perfect platform why IoT technologies can be considered as one of the key technologies for sustainable development of human society. So I start with my first pitch, okay, on this IoT for sustainable society, which is IoT for health, right? And I hope that you will find this interesting. But before I go to IoT for health, I will again take a pause, and I will try to take any questions if there are. So you can ask me questions, or you can just put into the chat window. I can answer. If you have any questions, please let me know. Do I have anything in the chat window?
Hello, participants. If you are in this diary, you can share.
Okay, if I anything in the chat window, no, not yet. So I will again ask all the participants, if you have any questions, please let me know. I will be happy to answer. Okay. What are the basic fundamentals for IoT-based applications? Okay. So Professor Shantanu, the basic fundamentals of IoT-based applications are, okay, you need to know about the end devices, which are called the IoT devices. Then you have a communication interface by which the IoT devices communicate with the immediate gateway. That can be your edge node or fog node, where the data is aggregated from the various IoT nodes. And then you need to analyze this data and need to do the prediction, classification, okay, type of activities based on the data. And that you can also do on the cloud also. You can just send the data from the device to the cloud and you can do the same thing. So I didn't touch the basics here, okay, considering that the basics I already covered in my lecture, in my first phase of lecture. And but you can get into, that means you can, okay, you can connect with organizers to get the first phase of my lecture, where I have briefly explained all the components of an IoT system, how the devices to the different nodes in the network works. And you can also get a lot of this in the existing literatures. Okay, so IoT in a sense is a combination of computing and communication, right? So communication works from the collection of data and communicating the data to the wireless communication channels to a central hub. And there the data is being gathered from multiple devices, and there the processing is done. And the processing may be to predict your health condition. Processing may be to predict the activities which are going in a room. Okay, processing may be to predict the quality of the environment at present point of the time. So this may be the different types, or maybe the autonomous vehicle is moving in the road and collecting the data from the different sensors and trying to generate the proper speed and the proper direction the vehicle needs to go. So these are the different types of actions which we generate from the data gathered by the various devices, right? And all these devices actually takes the help of the communication channel, okay, which is a network or internet, and okay, that's why it's called the Internet of Things. So am I clear to you, Professor Shantanu? So if there are no more questions, let me start my next part of my lecture. Okay. But I will again ask all of you to put your questions in the chat when I give pause. Okay, I will go back to your queries and I will answer them. Okay. So let's start the discussion, okay, on the IoT for health, Internet of Things for health, and we all know at this that health is one of the most important aspect of our human life, right? We do good if our health is good. We often do bad if our health is not good, right? And in the present pandemic scenario, we are all we have felt or know that how important is our health, not only for us, but for our entire human society. Okay, so let's move. So this is one important, very new and very important applications, and one of, okay, it's called the implantable glucose monitoring system. Okay, this is an IoT based system which actually measures the glucose, okay, in your blood. Why this is so important? Because you know that many of the casualties, okay, happens because the person glucose level actually shoot down. Okay, shooting up is one thing, but shooting up will not lead to immediate casualty. But that is also not good. Right? Okay. Again, I'm not a doctor. I'm just actually going through the common knowledge what each of us have. So but falling down of the glucose is again very catastrophic if you don't take an action within a few instants of time. Okay. So measuring glucose at different intervals of the day, there are some procedures. There are some procedures where you can, the doctor advises that, okay, for your patient, you have to take the glucose recordings for different intervals of your day. But if you think a scenario of working crowd, or working people, okay, the people who are at work, right? They will be not bothered about what is happening about the glucose level, unless there is an impact of that. But what you need to do before the impact, you have to do the proper thing so that the impact doesn't affect you. And that's a procedure what is being actually planned in this, okay, in this particular type of sensors. Okay. So this implantable glucose sensor. Okay, this implantable glucose sensor is actually what actually gives you that facility. So the way it works is something like this. Okay, so this is your implanted sensor. Okay, this is your implanted sensor, and this sensor communicates with your smart device. There is an app. There's an app, okay, which actually, okay, is there, right? And whenever there is a dip of the glucose level or shoot up of the glucose level over the thresholds, right? You will get an alarm in this particular app, and you know that you have to, okay, take a medical advice, or you have to take some medicines so that your glucose level can restore. This is a beautiful application, and this has been very recently, okay, been permitted by USA FDA. Okay, they are the authority for the approval of the different types of medical devices, okay, or drug-related devices. So this is the thing, and though there are a lot of okay, positive and negative about this, there is something that whether it spreads infection. Yeah, this is one of the issue, because whenever you try to do something inside your tissue, right? There are some ways that means, and you puncture it. There are some possibilities that the infection can happen, right? Other than that, there is no such adverse comment on this particular product. Okay, so how it works, I'm not going into the exact biochemical procedure, because there is a biochemical procedure by which the sensing occurs. Right? Again, I am not an expert on that domain. I am not a sensor expert. I work on IoT. I work on the sensors which are available. So but just to give a little idea, this sensor gets into your tissue and tries to, and there is a sort of proximity sensing, which actually tries to look into the glucose data of that particular of the blood flow, right? And this is heavily characterized so that the difference of the blood of the glucose level can generate different sensing values. Okay, and so on that the alarm on the app is set up. And then also what it does, it can also record your data. Sometimes it's also required that how your glucose level is varying. May not be you are taking a definite action, but it also requires a history data of your sensing, right? And that also that helps you in this particular device helps you in that particular process. Okay. Okay. So this is the very interesting sensor. Another type of IoT-based, very well-known system is something like activity tracker, right? And this is, I don't know whether you are able to see the entire figure. But you see that what I shown here is that, so these are different ways. These are the different sensing ways, right? You can actually get your vital body parameters. Okay, all of these are not coming from the same type of sensor, and it is also true that that means at any point of time you are not having all sensors. But what I have shown here is that I've shown a superposition of all possible sensors. Okay, you may have only 2 of these sensors or 3 of these sensors. Okay, but ultimately, okay, there are activity sensors, different types of activity sensors, either activity of your physical movements or activity of your body parameters, internal body parameters like ECG or EEG, right? Respiration. Okay, that is and also something like when you have a sort of portable type of scanning or some sort of those type of devices where they can collect the data and scanning data and can record that and can transfer them. Okay, so you see that these are different types of so what they do actually, what the sensors do, the sensors actually gives the activity condition of your body. So it is like bathing, okay, eating, toileting, heart rate, dressing, walking, in pain, okay, sleep stages. So you see that that means based on the data collected on the device, okay, you can classify the action, okay, what the person is doing, right? And this action is very much important to understand, okay, how much the patient has been affected by the disease. So this is normally done. Okay, this is normally done. Okay, maybe we can do that before the application of the drug, and we can monitor these activities after the period of application of the drug. Okay, or during a period after the application of the drug. And this actually gives the state of the state of the patient very well compared to a particular data which the doctors can take compared to a clinical test. So many of the doctors are now advising the patients to have this activity sensor, especially for the cancers. Okay, cancerous patients, because you know that cancer is a typical disease where the cancer can occur or detected in organ 1, but the cancer can spread into organ 2 or organ 3, which is still the doctor didn't find it out, right? This is called metastasis. Okay, metastasis state where the cancer from one origin organ spreads to some other organ. So this activity detection actually lets the doctor to understand that what is the overall condition of the particular patient, right? And there are a lot of research activities, a lot of IoT-based applications are being developed in this particular domain. This is also a very important important aspect which is now being taken care of. Okay, so I got to mention activity detection is also one of the important aspects of elderly people monitoring. We are monitoring the elderly people. Okay, so part of that also medical alert systems. Okay, there is a very simple band, okay, which the patient can press, right, and it actually gives the information, okay, and through the mobile device. Obviously, there is a, okay, that means it can have a communication in, okay, in that particular band itself, or from the band it can go to the nearby mobile device, and the mobile device can communicate that, okay, to the doctors, okay, and to the near relatives of the particular patient, right? And this is very important for the people who are old, right, and those who don't have any person who are taking the care 24 hours. So these are the systems which are used for those type of support. Okay. Ingestible sensors. This is also something which is very well known, right? So what this actually does, these are some sort of okay, sensors, very sophisticated. Obviously, it's not it's just like a common pill, but it's a drug pill with which we have a chip and a sensor which is ingestible, which means that you can take it inside. There will be no adverse effect, and it will just come out of your stool, or it will be just destroyed, okay, inside your body. So this particular pills actually gives the data when it goes into the body, and it also gives that information that how much the drug has reacted, okay, with the particular organ, right, by the data it gives. Right? And the data goes from the sensor to the body. It goes to the immediate handset or the smart device, and from there it can go to your doctor's end to the cloud interface, right? And those are so the doctors also knows that you have taken a pill, first of all, and doctors also knows that what is the effect of the pill, okay, which has gone into your body. This procedure can also be used for diagnosis of your body. Okay, there are some techniques by which this type of capsules gets into your body and move across your different organs of the body, or a particular region of the body, and tries to give a lot of data. Okay, and through that data you can analyze what is the condition of that particular organ of your body. So these are again tremendous importance, and obviously I think these are in the preliminary stages, or these are some sort of first-hand applications. I think over the time this will develop to a lot more. In this scenario of our work, right, where we are really not very happy because our friends, our colleagues, our relatives, okay, we are listening not very good news from this of our friends, our colleagues, and our relatives. So we are not in a very good frame of mind. So this is also one of the applications which people are trying, that whether you can have some variables and we can detect the body parameters, and from the body parameters can you detect the mood, and from the mood can you detect the mental condition, or at least the mental stability of the particular person. See, this is very important in the case that when a person when the scenario is very depressed and the person is also suffering, okay, then the mental condition of the person needs to be well known, so that he doesn't, okay, goes below his or her esteem, right? And that will be more dangerous, okay, for his or her survival. So these are people are trying to actually map the EEG type of sensors and the blood flow and skin conductance. So blood flow, skin conductance, and EEG sensors, okay, gives you the data, right, which can actually map to the emotional conditions. Obviously, we require a lot of prior data to generate this particular type of models, which can map our given data to a specific particular mood or a specific particular emotion. But these researches are there, and there is some good outcome of these researches. Okay. So I will again give a little bit pause, and I see that there is one question which is coming. Okay. Oh yeah, no. Okay, so this is one question which has been put by the organizers. Okay, fine. So, so this I have just taken some of the snippets of IoT for health, right? And there are many more to explore. With the limitation of time, I'm not getting into everything here, but I have just tried to tell you that what are the main directions which have been taken in this IoT for health in terms of sensors and binding the sensors with a smart application, right? And making it very effective, okay, for the community. Okay. So if you look into so now what you do using the data. So this is very important, because though I shown some fancy applications in the background, okay, you have the data. The data is actually driving us. So now if you look into the data, right, and we try to analyze the data, right, you can get certain insights of the cause of this disease, okay, or the actual impact of this disease, right, the factors related to the disease. Because if you know all these things, then only your actual, the direct, that means your remedy or your therapy will be perfect, right? And that's why the doctors are trying to use this type of devices to get the data of the patient. So if you look into the way we can visualize the data, okay, we can visualize the data something like the impact of social and environmental impact. Okay, like the population, the aging count of the population, or the aging characteristics of the population, the urbanization, and the globalization. So we find that some of the diseases, okay, it can happen in a particular urban setup, which will not happen in other setup. There are some diseases which actually gets maximized due to globalization, right? As people are moving from different ends of the world, different parts of the world to other parts of the world, right? You see a disease pattern which is getting spread with that. So this is also a particular observation which is there we need to know. The second observation we need to know is basically the factors which are actually causing this particular disease. Okay, that means I'm not telling that you have sensors for everything, but what I'm trying to tell you is that what are the problem domains we need to understand. See, if I want to design a sensor for the health, okay, sensors or the IoT application for the health domain, what I need to first understand is that what are the problems in this particular domain, so that we can cater the requirement. So the requirement we have to at first understand, and then we can develop the technology, and then we can provide a solution so that it can be worked upon, right? So now I'm trying to tell that what are the areas, or what are the different types of features we have in this particular health domain, and so that whether can we build sensors, can we build the IoT ecosystem, which can at least get these particular factors and help the medical practitioners. See, we engineers are just actually trying to help the medical practitioners with our technology. Okay, we are having no knowledge of medical practice. But what we can do, we can actually try to look into the medical problem and try to map it into the data space, right? And try to find out how you can get the data, which particular technology can give me the data. Okay, so if you look into the space, you will see that there are the factors in the health domain. Some are changeable factors, some are unchangeable factors. Changeable factors are those which means that, okay, you can tell your patient that, hey, you don't do this, hey, you don't do this, hey, you do this, okay? So you define a code of conduct, okay, or a practice what the patient has to do, and if he or she follows that, okay, you have actually done some considerable amount of control on that. But there are some factors which are unchangeable factors, like your hereditary factors, okay, like your gender issues, okay, like your the country where you live, some tropical climate, our climate. Tropical climate has its own hazards, right, which are not there in the climate, maybe in the upper Europe, okay, or in the other continents. So this is something also very important in the health, right? And then comes the diseases. So what is the actual disease condition? Okay, exact disease condition. So this particular okay picture tells you about the different types of data we need to gather to know the health condition of a particular patient. Okay, right? And again, if we look into the mapping, the influence factor, this is also taken from a very phenomenal content presented by Professor Jean Claude. Okay, he actually presented this in one of the meetings, and that data tells us that hey, that the influence of the human health, okay, if you try to characterize by the different sectors, okay, something like that: lifestyle, biology, environment, and healthcare facilities. So these are the different influence, okay, on the human health. This is also based on some study. So now, as I told you, that there are different types of sensors, but these sensors are sensing the body signals. This is very important to understand why I have coined the term body signals. I have coined the term body signals because we are accustomed to signals which are coming from different sources. But body signals are also signals, but the sources of which, okay, are basically the internal processes of your body. And so it is a different type of signals, and you have to, it is not true that a particular understanding or processing a particular signal and understanding or processing a body signal will be exactly the same, right? And that's why the different type of approaches needs to be taken when we collect the body signals through our different types of devices. Now, if we look into this particular type of modes of communication also, modes of communication is also different, or the intervals of communications are also different. The body signals have different intervals of communications. Suppose we are taking the ECG signals, okay? Suppose we say ECG signals, they have a particular periodicity. Suppose we are taking the body temperature, their variability is of different order. If you are taking the heartbeat rate, okay? That was, I've taken the ECG, sorry. So suppose you take the take the EEG signals, okay? So they are again of different orders and different frequencies. So this we have to consider also, that it is the first factor to consider, that when we're trying to analyze the signals, these signals are different signals than compared to the signals which we have from naturally occurring sources. Okay, these are body signals. And secondly, the different organs which are generating the body signals have their different way of generating the signals. So their source models are different. And so we cannot just put the same analysis window for all the signals. And this variability leads to the scope of immense research in the different types of body signals and how we can analyze those body signals. Okay, I hope I have tried to make you understand that what is the exact challenge here in the healthcare monitoring system. Though it seems to be a very pretty or common word that, hey, I am trying to analyze the signals, okay, of my body. I'm trying to develop a healthcare monitoring system, but it has a huge amount of variability. And I didn't also speak about the noise it can have, because always your body is influenced of some external conditions. You are not having a human body in complete isolation of your external conditions. So there will be always noises which will be coupling with your captured devices. And that you need to some way neglect or some way take off to understand the body signals in an exact way. And that's also another type of challenge. Okay. So as I told, okay. So as I told, when I look into this type of devices, okay, there are different types of challenges. Okay. Okay, and obviously there are benefits a lot. Okay. So if you look into the benefit, now this particular okay, health devices are low cost in normal sense. People are doing a huge amount of research so that the cost can come down of these devices. They are making it miniaturized. Some of the devices are connected with your smart device. Like if you have the Apple Watch, right? It is giving you the SpO2 measure, the oxygen saturation. It can now measure, okay? It can measure temperature, it can measure the blood flow, okay? It can measure your heartbeat rate. So all these are now coming within a tiny device, which is a reduced in size. It is ubiquitous. It is not that you have to take the particular data in a particular proper position in your room, okay, in a particular position. You can just move about. You can move around, right? And you can still get all the body parameters recorded. Right? It's pervasive. You can be here. You just require a sort of power so that the data as a device can be powered up, right? And you require a communication interface, okay, by which you can upload the data. So you're in which part of your city, in which part of your country, it doesn't matter, or which part of your world, it doesn't matter. It still communicates, okay, it still generates the data, and the data reaches to your medical doctor, and the analysis can be done. Okay, and it can give different levels of information, as I told, that it can couple the data from different sensors, and it can give you a very holistic information, right? It can give you a periodic information over the time, right? It can give you the information with your taking your food or after taking your food. So different types of information can be generated to this particular sensors, which is not possible. Again, I'm telling, which is not possible for a doctor to gather just by having some fixed appointments with the patient. That's why it is so important. So a doctor can only meet the patient in some fixed appointment intervals. But this data collection can give the information about the patient over different dimensions. Okay, over a period, over different actions, over the drug being administered, right? Over the different environment of his or her, where he or she is living. So this type of holistic data can be captured using this type of devices, and so they are so important. Okay, and people are working so that the device is made better and better, accurate, and they can be low cost, they can be pervasive, all these things. But there are certain issues. I already mentioned. One is called the standardization. The second issue is a big issue, which is the 5G. Right? I think some of you know about 5G. So 5G is basically a huge bandwidth, right? A 5G network can actually capture a huge bandwidth. So the amount of data these devices are generating, this leads us to the requirement of 5G. Having said so, 5G deployment is still very costly because 5G transceivers are not so cheap. 5G transceivers are very costly. So if you are really gathering the data of a patient in a ward, suppose you have 100 patients in a particular ward, and the doctor is trying to get the data of all these 100 patients. Now the amount of over a 3 or 4 or 5 days or 7 days of time, it's really a huge amount of data, right? And to communicate that, and the interval period may be minutes. Some data may be minutes, some data may be hours, some data may be different halves of the day. So you see that there is a huge amount of data which is generated, and to collect the data, okay, you require a sort of large bandwidth network, which is 5G, right? And obviously the communication bandwidth, the communication energy, all you need to take care. The second, another important aspect is that the data model. Data model is very that means have a lot of variability in the particular medical domain, right? The model which actually that we have seen, the coronavirus model, right? Very that means we have tried to generate very good models, and we claim that we have generated very good models, but many of the fact tells that the models failed because the data models for health are not so easy. There are so many parameters. So you know that when a model involves more and more parameters, the model becomes complex. And it also has a temporal nature. It is not static. The model, that means the data changes with time. Right? So the model is a dynamic model, first of all. And above all, it has a lot of features you need to take care. And so the model becomes complex. Privacy, I've already told that you are working with patient data, and it shouldn't go to wrong hands so that the patients are endangered, and you're working with a large population. So to maintain the privacy of your data, which is a large amount, is also a big challenge. And all the challenges leads to the technology needs to be scaled up, okay, in the domain of medical IoT, or it's called MIoT. The last but not the least, who is the owner of the data? Suppose I have bought a device from X manufacturer. It's sensing my some of my bio signals, and it's communicating it to my doctor. Who is the owner of this data? It is my data, right? But it's captured by a device which is manufactured by X, right? And I don't know whether X is also pushing the data to their server when it's communicating, because it has its own communication protocol. It has its own software which communicates with the server. Okay, and the data goes to the doctor or the medical end, right? And so the data is everywhere. Now, who has the legal? Because the doctor can use the data for his or her research. The drug company can use the data for their own research, for developing the developing the device better and better, but the data is my data, right? So do they have the proper permission automatically, or we have to make some regulatory process so that if the data collected from the devices will be used for the benefit of the society, or for business, or for education, how they will be properly used? What are the rules and regulations? There are something called ethics in medical, and normally when we do research in this domain, we try to figure it out in the platform of ethics, how we'll go about the ethics of this particular data, and that's the most common way we do that. But whether there are any other implications also in this domain, that's also needs to be thought about. Okay. So I think I can give a pause because a lot of questions have come up. Let me go one by one. Okay. Okay. No, these are not. These are again all administrative questions. Okay, fine. Okay, so not much questions on my lecture. Okay. So if you have any questions, you can again put in the chat box. I'm continuing my lecture, but I will stop maybe after some 4 or 5 slides from here. Okay. So from this, there are different types of terms which have come across when we tell that health monitoring system. So health monitoring system is a very global term. From this global term, a lot of different terms have been coined. Okay, one is health cyber physical system. So cyber physical system is a very well-known term, which means that the physical systems which are connected to the cyber world. It is another way we tell IoT, but IoT normally tells about on-field systems. But cyber physical systems may be gigantic also. Okay, it may be any system which connected with the cyber world. Right? You can, in that sense, you can tell cloud is also a cyber physical system. Right? So that's the domain of cyber physical system. So these devices which are actually taking your data, okay, taking your health information and are communicating, okay, can also be coined as a sort of okay, this health cyber physical system. There are something called mobile health monitoring, which are basically, there are a lot of applications which are built up with the smartphones, right? And using those smartphones, you can you can actually communicate a lot of your data, and this becomes a mobile platform because your smart device is a mobile device, and wherever you are moving, you can still communicate your data. Okay, using a smart device. The third part, the third type of activity is called wearable computing. Okay, where I have just shown a device which is implanted and wearable. There are 2 different terms. Implanted means which are actually permanently seated on your body, and wearable means, okay, it's just like a strap or just like a jacket which you can wear or you can remove. So there are straps. Okay, there are straps, there are jackets which have these devices, and when you want to capture the information, you can put on the strap, you can put on your wearable device, wearable jacket, and your data can be captured and you can communicate. Okay. Health Internet of Things or medical Internet of Things is basically the sensing and the devices and the network in the very fundamental level of IoT. Okay, if you are generating some data, you're communicating with your edge devices or fog device, and you're pushing back into the cloud, and you're again taking the inference from them. If it's an upward and downward flow from your device to your cloud, and from your cloud to your device, or from device to your fog, or from fog to your device, it's called a health Internet of Things type of system. The other important type of this application or systems are ambient assisted living. Now, assisted living is a very, very important term, okay, for many of the countries. In the many of the countries, the old people, okay, doesn't have their younger generations with them. Younger generations live in a different city, and the old people live in a different city. And the old people are always at a risk. Okay, their health conditions, whether they can do the body activity properly, or whether there's an accident, the person fell in some way. So all these informations needs to be captured and needs to be communicated at the earliest to the doctor as well as to his near and dear ones. Okay, and this is called an ambient assisted living. And this practice has also been started in many of the places in our country too. So it is a sensing technology, okay, which actually tries to give a better life for the people who have some restricted movements. Okay, and through that they can connect with the relatives, caregivers, and healthcare experts. And obviously, the technology is very much based on sensing to various means. Okay, audio, video, text, all this type of sensing. Okay, movement sensing, actuators, all this. As well as they use a lot of this analysis and machine learning at the back end to predict the condition of the particular individual. Last but not the least, this healthcare monitoring system can also be defined as body area network health monitoring system in many of the cases. So the term body area network is being hired from the network topology. So a network communication can happen, okay, in different dimensions. The common dimensions are a LAN, WAN, MAN, something like this. But BAN, or body area network, is something that where the devices which are connected within a body, different segments of our body, they can communicate with each other, and they can communicate with the master node, and they can transmit the entire data to the cloud or to a smartphone. So the mutual communication, okay, between this particular devices can be done through a different type of network, or a network which is commonly known as body area network. Okay. I will just stop the screenshot and restart it. That will be better, because I saw there is some scratch in the screen. So, okay. So now this, okay. The other interesting part I want to highlight is that there is also something which is being coined as healthcare robotics. Now this is a little bit different from the thing which we discussed till now. Till now we discussed is that, okay, we have devices which can capture different types of body signals in different forms, okay, in different time intervals, and will communicate to the cloud, and so the decision will be taken by the doctor. And the doctor prescribes medicine, or the doctor sends an ambulance to carry the patient back to his medical center, or the doctor visits the patient at home. So these are the things which can be done through this particular type of devices and communicating. Now, the next generation is that a therapy which is practiced at the point of care. So it is not only capturing the data and knowing the condition of the patient, but also trying to help the patient. Okay, also trying to help the patient at the point of care. So this is a sort of robotic assisted with a cloud backend. So what we can consider here is that there is an entity which captures the data, pushes the data back to the cloud. Now the cloud analyzes the data and tells the agent what needs to be appropriately done now. And this is what is a healthcare robotics. So that particular robot will work as a caregiver. It can be very simple. It can be a chatbot also. It can be a chatbot application. What it does, it actually, the sensor data is captured, is analyzed at the cloud end, and then it pushes the actions through a chatbot to the patient that, hey, you have to take this medicine now, or hey, you have to increase the dose of the medicine, or hey, you have to reduce the dose of the medicine, or hey, you have to take rest now for maybe for the next 2 hours, okay, or you have to take food immediately. So this may be a chatbot, this may be a physical robot also, or this may be a physical equipment which is assisting the particular person, okay, to give him or her the support. So this is a very interesting phenomenon, or this is a very interesting interesting application, which is now becoming popular in the healthcare domain due to the reduction of the medical support staff at many of the occasions. And it has been seen that this type of applications, okay, where the robot will be constantly connected with the cloud and taking the directions from the strong analytics as the cloud develops based on the data or the medical condition of the particular patient, and tries to do the appropriate action. Okay. So now I am moving into a little bit different paradigm, okay, of the entire of this particular ecosystem of IoT. Still now we were talking more about the devices, the communication, and how the interfaces, how the entire ecosystem will work. But now what I am pointing towards is focusing on the data. What type of analysis we can do on the data? Because this is of very important. Okay, very, okay. Yeah, this is of utmost importance. Okay. Now, obviously, we know that there are certain ways that data can be handled, processed, and inference can be generated based on your data. Inference can be generated based on the models which works on the data, right? So there are some steps. Step 1, capture. Step 2, normalize. Bring everything in the sort of same scale. Okay, because different sensors are producing data in different scales. If you want to drive your model, right, you have to present the data in a particular way, in a particular scale. Right, so there are some sort of normalization. You can just take the max and divide the data with the max, and everything will be between 0 to 1. Okay, right? Or you can take or you can calculate the mean, and you can try to try to scale it between 0 to 1. Okay, you can scale the mean at 0.5, and then you can scale the different data across the 0.5 using the standard deviation what you have in the data. So there are different types of ways of normalization what to do with the data, right? You have to put the data in the proper scale so that you can analyze the features. Now there is also another important stuff in the medical IoT when we're working with multiple devices is called which is called data fusion. Okay, so data fusion or the multi-sensory fusion is also very important. Okay. To understand this, what we're trying to build, we're trying to enhance the feature space. So what fusion does? What fusion does? Fusion enhances the feature space, okay? Fusion enhances the feature space because suppose you are taking the data of your heart rate, right? It can give you certain parameters of your heart, but you're also taking the data of your blood sugar data. You're also taking the data of your oxygen level. So these are all independent parameters if we consider them. Obviously, we've got a medical suggestion for that, whether we want to do independent parameters. But if the independent parameters, then we can go and extend the feature space. And this feature space, by fusing the different types of features coming with different types of sensors, will give me a better distribution of my data, which will help me to classify. So the problem becomes a bit complex, but it will give a more error-free classification and prediction. Okay. Now, when we try to work with the data, this is called intelligent care algorithms in the most common name, in the most common form. Okay. So these intelligent care algorithms can be applied for different ways. It can be an alarm generation application. Okay, you need to have a medical emergency. So you need to be immediately taken by, that means immediately medical attention is to be taken. Okay, it may be a progress of the procedures you need to do. Okay, you need to invoke a clinical decision support system. Okay, you need to push an injection or need to do some sort of drug you need to take, administer, and all these things. So it's a clinical decision support system. Okay. Asset management. Asset management is obviously this is on the side of the resource end, right? How much amount of resources are required to support this, and that is and in the present pandemic phase, we all know that asset management is becoming a very important criteria of preventing this outbreak. And similarly, asset management can also be done based on the data coming from the patients. Okay, and it can help in clinical research, and it can help in generating lot of analytics at the cloud end, so that it can be useful for a long period of time. Okay. Now, when we look into the data, there are how we go forward with the data. What is the analytics progress here? So we know that it can be considered in four forms. Okay, one is the what has happened, why happened, and what will happen. So it's called the movement from the hindsight to the foresight. And this is very important in the context of medical analysis, because doctors exactly do this thing. The doctors exactly the term prescriptive analytics has been borrowed from the prescription which the doctors give. What the prescription tells that what you need to do from now onwards. Okay, what we need to do now so that you can prevent the disease. So this is something you need to do from now to some future point. That's called the prescriptive analysis. So descriptive, which tells you that what happened. So you need to understand actually what has happened. What is the present condition of what is the present disease condition of your patient to the analysis. That is one type of analytics. Diagnostic, whether you can correlate the disease condition with some existing records or existing information what you have, and can tell that, okay, hey, this has happened due to this. Now, predictive. What can happen from this onwards? Okay, there can be a chances of heart attack. Can be a chances of a damage of an organ, or the growth of a tumor. It's a predictive. So what needs to be done? Prescriptive. Okay. So now, what is the way I can actually stop this particular progress of the disease? Okay, or actually just actually cure this disease. What are the steps we need to do? So a doctor actually is an intelligent person. Okay, he or she actually does all this analysis based on their findings, clinical findings. Okay, but whether based on the data, our analytics engine can also be developed so that they can also generate this, and they can help the doctor in treating the patient faster, which means that if a support is there with the doctor can actually work faster, and he or she can cater more number of patients. Okay, so this is the motivation of the entire analytics to make this very appropriate for the patients, right? And that is the process your analytics should work. So I will just stop here, and I will try to check if there is any questions from the audience. So if you have any questions, let me check the chat. No. Okay. How machine learning is associated to drug delivery? Okay, very interesting question, Dr. Shomik. This is a very interesting question. I didn't work much in this domain of drug delivery and machine learning, but the idea what I have from my medical friends and people from biochemistry, what I see is that there are now different types of ways, but planning. It is called the planning for the drug. Okay, people actually tell the planning. Okay, so the planning involves a lot of data, right? It takes the data of the food habit. It takes the data of the habits like smoking or any other type of habits. It takes the genetic, that means in some cases, okay, in some cases some sort of analysis, okay, okay, and based on those, they try to find that what is the amount of drug, okay, and which particular class of drug needs to be administered. Okay, because sometimes, many of the times, there is an intuition. Based on intuition, the drug is delivered. But whether this intuition can be driven by science, okay, that's one of the motivation, okay, of drug delivery. That means understanding the conditions of the patients and previous record of patients who have cured or who didn't cure, positive cases and negative cases we tell. Okay, can we try to find that what will be the exact drug, or what will the exact group of drugs, or what will be the quantity of the drug? Or also, actually, we are working in one project now, okay, with peerless hospitals. I'm not telling the exact drug or what we are doing exactly due to the confidentiality, but we are working that we are trying to find that the effect of the drug, or the drug response, okay, to the individual with time. Those all the things are being now, and we are doing machine learning. Our doctor is helping us with the with the inference, to building up the inference. Okay, and we hope that we will come up soon with a good paper, either in a good journal. So so this is one of the things which I know about how machine learning influences the drug delivery. But if you are telling the drug delivery means actually delivering the drug at the particular site of the disease, because that's also one of the way the drug delivery is being coined, that how the drug actually affects the cell of the disease cells. Okay, there people have started with some nano type of sensors where they can exactly guide the particular drug to the location, and can selectively actually hit the disease cells, and can just keep the healthy cells untouched. But how machine learning is used for those applications, I still that means I didn't have the chance to go through those studies. Okay. So did you get the answer, Dr. Poddar? Okay, good. So any other questions? Yeah. Can you just tell? Yeah. It's not very clear. Can you just again repeat? The audio is not. Yeah. Yeah, you're audible, but your voice is breaking in between. But I will try. You just. Yeah. Artificial intelligence is, what is the difference between? Okay. So the question is related to artificial intelligence, related to pharmacy, right? Can you type the question in the chat? That will be very, very helpful for me. Yeah, can you just type the question? Yeah, can you just type the question in the chat room? Okay, how artificial intelligence related to IoT? Okay, good. Okay, good question. So artificial intelligence means what? Artificial intelligence means that we are making agents, intelligent agents which are built artificially, right? So intelligent agents means that who can act appropriately. So the entire ecosystem, what I discussed in the domain of IoT, or maybe emphasize on medical IoT, right? Obviously, at the present point of time, we mostly speak about machine learning and deep learning. But when we tell machine learning and deep learning, remember, these are also making artificial intelligence systems. So the entire stuff of machine learning and deep learning is also under the purview of AI, right? So we will try to discuss a bit of machine learning in the slides coming up the next, and we will show that how machine learning and deep learning can help us to analyze the data which are generated from IoT. But one thing we need to understand is that it is not that IoT is using AI or machine learning, but that means having said so, it is also true that people are going forward to that. People are trying to go that intelligent deployed IoT systems. But the IoT systems will try to understand that what are the good locations where they will be deployed, what are the good points of time they will be generating the data. But those type of things we are not discussing, which I'm okay. So if I restrict my discussion, okay, here the motivation of AI with IoT is that the IoT, that is in the IoT framework, we generate the data to the end devices, and that data is analyzed, okay, through machine learning and deep learning strategies to generate an inference on which an activity will take place. And that's the way IoT and artificial intelligence gets connected. Okay, so the data generated by the IoT is being used to drive an artificial intelligent agent, from which we generate the inference or the activity plan. Okay, so I hope the answer, you've got the answer, right? So any questions regarding this? That is the entire process of health monitoring and analytics. Anyone wants to have a more discussion on that? Okay, so if not, let me go to the next part of my discussion, which is actually the analytics part. So as I have discussed that what I will do with the data. I'm collecting the data from the sensor, and the data is being aggregated to the edge node or to the cloud node. Then what happens to the data? The data can be analyzed for prediction, for predictive analytics. Predictive analytics is the most common. Predictive analytics means that I get the data, I tell you that, hey, this particular data is from a diseased patient, or this particular data means that the patient is good. So it is a very simple, that is in the very simple form, in a very simple understanding, we can take that this is a diagnosis. Diagnosis means that understanding the disease condition of an individual is called diagnosis. Okay, so the diagnosis, what we can do is based on predictive analytics. So this is an example of the data, right, which actually gives a hyperlipidemia, which is some condition of obesity. Okay, some condition of obesity, and which depends on the value of triglyceride, cholesterol, okay, lipoprotein, high density lipoprotein, low density lipoprotein, and then this is the level. Okay, so this is the class level of the data. Okay, so this is the class level of my data. Okay, and mind it, what I'm trying to do, I'm trying to use the this particular curve which I show is called a logistic regression. Okay, and this is basically a classifier. So classifier means it's a supervised learning paradigm. So the supervised learning paradigm, I will try to train my classifier with the data. So this can be considered, okay, this entire data, okay. Is my training data. Okay, or I can split it a bit, or I can split a bit. Or I can split it a bit. That okay, some is training, and some is test data. Okay. So this is a supervised learning model, logistic regression. And logistic regression, though, is a regression, but it's a binary classifier, right? It classifies the data into two levels. So one is the diagnosed disease, and one is the healthy. This is the positive, this is the negative. So So I can build classifiers like this. Is the one of the example classifier. Doesn't mean that you have to build logistic classifier. But if it is a binary classification, you can try logistic regression. Okay. Though you can also try SVMs also. It's not like that SVM will not work as classifier. Okay. There is other classifiers are also there. Okay. But so this is a type of approach we can consider. Okay. And any classifier you need to train, you need to know the hyperparameters. In the case of hyperparameters, here is something like it's a sigmoid curve, right? And there are parameters which are beta 0 and beta 1. Okay, beta 0, beta 1, beta 2, beta 3, because there are so many parameters. So there are beta 0, beta 1, beta 2, beta 3, which are associated with all the features values. Okay, beta 0 can be your bias, and then beta 1 can be associated with the feature 1, beta 2 associated with feature 2, beta 3 with feature 3, like this. And what you have to evaluate is that you have to approximate the values of beta 0, beta 1, beta 2, beta 3, so that you can build your model. So building your model means you have to estimate the hyperparameters of your model. And once you estimate the hyperparameters of your model, you can always evaluate the y. So there is something that y equals to beta 0 plus beta 1 x1 plus beta 2 x2, and it goes on. Okay. So what you have to do, you have to, first of all, that means with the training data, you have to estimate the beta 0, beta 1, beta 2, beta 3. For each parameters, you have, that means for each of your features, you have one parameter in your model. So you have to first estimate the beta 0, beta 1, beta 2, beta 3 with the data given to you, right? And there is a process called some sort of gradient descent process you can take care. Okay, and you can find what are the best values of beta 0, beta 1, beta 2, beta 3, so that your predicted y, okay, your predicted y is something called y kappa. Okay, is very close to the actual y what you have in this particular training data. So more and more you get a match of y kappa to y, right? Your model is better and better, right? And then once you have a low error for the test data. So test data means the data by which you haven't trained the model. Okay, but you know the outcome of this data also, because you have splitted your initial level data into two parts, training and test. So your training data, you build the model, right? And your test data, you verify the model. And once you see that your error in the test data is also very low, that means, okay, within the threshold, you can now use the model for any data, okay, that means we generate. And once you push the model, once you fix the model may be logistic regression, which has two classes, class 0 and class 1. This is called the class 1. This is called the class 0. Then for any new data, you can just check that whether it comes under class 1 or class 0, because you know that beta 0, beta 1, beta 2, beta 3, all this. And so what you need to find, you need to actually just get the value of x1, x2, x3, x4. Sorry, not this one. Sorry. Yeah. So yeah. So this 1, 2, 3, 4 parameters you give and evaluate the y. Y may be class 1 or class 0. That's the way you do in the case of logistic regression. Okay. There's also something called Bayesian predictions. Bayesian prediction. Okay. The Bayesian prediction actually depends on the probability. So this is also a classifier, also called a naive classifier, because it is based on very, very, very simple postulates, right? And what it tries to do, it tries to work better for many classifiers. Okay, we can prove that naive Bayes works good for many of the classification problems. Obviously, it works good when we have the number of features within a limit. If you have a large number of features, naive Bayes is a difficult proposition. Okay, so the way the naive Bayes works is basically tries to find the probability of a particular parameter. So suppose we take this parameter as A. What we try to find? We try to find the probability of A. Yes. Okay. Probability of A being yes. Okay. And that leads to, this may be your Y. Y yes. So it is measure something like this, that I'm not going into basics of probability. A equals to yes, so sorry. Probability of A equals to yes, provided Y is yes. So can you tell me what's that? Who can answer? Probability of A is yes, provided Y equals to yes. So see, you have, okay, you have yes. Probability of A is yes here, 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 and here. Okay. Right? Okay, I think I did a mistake. Don't put Y equals to yes here. Okay, it will come later. Y equals to yes. Okay, don't have to do Y. Okay. So now the probability of A equals to yes is something that, okay, out of all these Y's, you have 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So it is 1, 2, 3, 4, 5. So it's 5 out of 9. Okay, it's a P A equals to yes. Okay, and similarly, P no equals to will be 4 out of 9. Okay, and similarly for the blood sugar also, as it is. So these variables are categorical variables. Okay. A is a categorical variable. Categorical variable, but B is not. So it's a little bit difficult when you have a numerical value, but you can still do. You can just try to make a mean, and you can try to tell that, okay, the values which are higher than mean is a high, and the values which are lower than mean is a low. And that's the way you can convert it to a category variable, right? Right, and once you do the category variable, you can actually do this particular experiments. Okay, so predict the class level of a person who received health examination. A equals to yes, and B equals to 7. Okay, so if you look into these ratios, okay, P yes is 4/9, and P no is 5/9. This we have already evaluated. Okay? And A equals to yes. Okay. For the yes cases. Okay. So this is what A equals to yes for the yes cases. So yes cases are 1, 2, 3, 4. So out of these 4, yes cases 1 is no, but rest 3 are there. Okay. So this is what is called 3/4 of PA equals to yes by Y equals to yes. And this is PA equals to no and Y equals to yes. Okay. So this is the way we calculate for all the variables, right? We try to calculate the values of the probability of of the different values of A, okay, for the different classes. So what are the classes here? So classes here are basically the values of Y. classes are yes and no, which are from here, right? Yes and no, right? And variables here are A and B. So we try to do A yes for y equals to yes, A no for y equals to yes. Okay, A yes for y equals to no, and okay, and we do A equals to no for y equals to no. Right. Now suppose we now try to find that given a particular value, what will be the class? So this is the way we try to define. So probability of class C given the value x is probability of x given the value C multiplied by probability of C multiplied by probability of x. So suppose let us take two problems. Let us take problem A equals to yes, and suppose take 7.9 is high. Suppose you take 7.9. Okay. Now I need to find out the class of C given A equals to yes and B equals to high. We have to use this particular formula because this, if we try to convert it here, okay, the formula here becomes P, okay, A comma B. Suppose we try to first we try to instead of C, we try to find C is here yes. Okay. Try to consider that we are trying to find the probability of yes. That is the okay. Yes, the disease is there. Okay. So the probability of A, B, yes multiplied by probability of yes multiplied by probability of A and B. Sorry, let's write it this way. Multiplied by P, A equals to yes and B equals to yes. So how do we evaluate these probabilities? There is another formula which tells you that probability of x1, x2, xn for y is equal to the product of probabilities. So this can be reduced by formula P A, okay, by the formula P A yes multiplied by B B yes, okay, multiplied by P yes and divided by P A equals to yes and B equals to yes. Okay, so now we evaluate this based on the probabilities we already computed, and suppose we find that the current value of P yes for A equals to yes and B equals to high okay, B equals to high is greater than probability of y equals to no when A equals to yes and B equals to high, then we tell that this particular condition where A equals to yes and B equals to high, as probability of yes is greater than probability of no, then it will go to the yes class, which means that if A is yes and B is high, then the disease condition is yes. So this is the way we try to use the Bayesian probability to actually evaluate the probability. So what do we do? What is the training here? We have to understand. So what is the, so the way we do the training is try to evaluate the probabilities, okay, of the different categories of each variable for each of the classes, and also the probabilities of each of the classes in the training data. And then we evaluate these probabilities and keep them. That is actually what we do in the training. Now in actual test time, in the actual run time, for that particular value, okay, in which category the value comes for the particular variables, for that category we try to measure the probability of a class. The class which gives the best, the highest probability, we actually map that particular data to that particular class and try to predict that particular class. Okay, so this is the way how the Bayesian classifier works. Okay, so logistic regression, Bayesian classifier, though they are not only these two classifiers, there are many more. So the main procedure of this particular type of activity is that hospital data. We are taking hospital data here, but I think better to coin as the IoT data. Okay, the IoT data. Okay, which okay, sorry. Yeah, this is perfect. So yeah, so this is not IoT data. Sorry, this is the training data. So training data should come from the doctor's end, because doctors will give me the label. That's why is the hospital data. Sorry. Okay, this is the training data. Okay, so training data will be prepared by the medical expert. They will label the data. They will label my data, and it will come from the hospital or the medical staff, medical expert. And that particular data, okay, I am the data analytics, okay, data analytics person. So I will build my model with the data. So I will split the data into training and test, and then I can have multiple machine learning models. We can try and we can find that which particular model will give me the best accuracy. Sometimes people also work with ensemble models also. People work with 3 or 4 models, and they try to find that a weighted combination of the models, or they try to find the majority. Okay, majority of the models tells a particular class, and that class actually gets, that class is being recommended. So there are different types of, not getting into details of those machine learning techniques, but you can apply different types of machine learning models to based on the data. And once your model gets done, then that model is ready to interact with your IoT data. Okay, and this will generate the inference, and from that you generate the action. So what I have done here, what is being done here is that this model through this particular setup actually captured medical knowledge, and that's what is the training. This is what is the learning. So learning means what? Learning means you actually capture the knowledge in a process, capture the domain knowledge in a process. That's called learning, and that's what is called a machine learned a machine learning model, because this model has captured the knowledge of the doctors. And now, obviously, our medical practice doesn't allow that models will diagnose directly. Models should be under the supervision of the doctors to diagnose. But you can see that this model has become a doctor. Once you prepare the model with the help of the doctors, then this model works as a doctor. It takes your medical IoT data, right, and predicts the disease condition of the infants. Okay, based on the, and that's what is the question what you told, that what is the role of AI in IoT. This is the same. This is the role of AI. The machine learning models, okay, built on the data. Okay, that is obviously where the hospital data means the hospital data has previously captured. So the hospital data is previously captured from IoT, but not directly passing to the that is not directly going to the inference engine. First, the medical IoT data captured from different patients is to be labeled by the doctors. Okay, and then it can be fitted to a model, and then the model can work under the purview of the doctor and can take the decisions. Okay. So this is actually exactly what we're trying to do. We're trying to generate. We are doing the data explorations because we require a lot of type of data coming from. So what I'm trying to tell, I've given a very simple example that data coming from medical IoT is not only that. The data can come from medical IoT. The data can come from patient history. There are a lot of other databases. It can come from drug databases. Okay. There can be different types of data can come from different databases, and the data needs to be explored. The data needs to be well connected. Okay, develop the feature space to understand, to analyze the data from all forms, and to try to generate the feature space as best as possible. Okay, right, and then actually the machine learning built up model starts up, and it tries to extract the patterns and tries to extract the knowledge out of that. Once it gets the knowledge, it develops the particular model. You can actually use that model. The knowledge is captured. The knowledge from a medical domain is captured, and that you can now use in your automated system, in your IoT-driven system for your disease diagnosis and prediction. Okay. So how much time I have? Organizers?
Hello, sir. Am I audible?
Yes, you're audible. Yeah.
Actually, sir, we are at the end of the session almost.
Okay. Then I will just quickly browse. Give me 5 minutes. Okay. I will quickly
browse
the last part, and I will come to the conclusion. So
okay, sir.
Okay. So while that means I will not now go into details of everything. Now, while I will tell that models, an important thing in the medical domain of building model is also transfer learning, which means that there are different types of diseases, and sometimes it happens that you don't have enough amount of data for a particular model what you are trying to prepare for a particular disease prediction, but you have a good amount of data for a related disease or some of the or a disease which also actually works with the same organ. Okay, suppose you're trying to find a brain tuberculosis, right? Brain tuberculosis is a type of a lesion. You have less amount of training data for that, but you have a good amount of data for a particular brain tumor. So brain tumor is also a lesion, but a different type of lesion. It is a different features compared to a brain which is tuberculosis. But if you have more data in the tumor, you can actually use that of learning the features, the baseline features of your domain, because it's also a similar domain of brain. Brain, actually the brain means normally MRI data. So it actually learns the features of MRI data, learns the features of the brain and the baseline. And then you use the transfer learning, which is actually then developing the feature space more concrete to the specific domain. Then you can use the data from your brain tuberculosis, and you can do a transfer learning, and you can make the model good for your tuberculosis detection. Okay, so this is also a standard practice which is done, which is called transfer learning. And this is a very much important aspect which is coming up, is called 5G centric healthcare system, because you have a lot of data communication, data analytics coming from the different devices, and 5G forms a backbone. 5G forms a communication network, which is very robust, which has a very high bandwidth. It's not only your data, you can also transfer image. It's so important. You can also transfer your sound, okay, that is, we know the applications like digital stethoscope, where you can also listen the sound like a stethoscope sound, and you can analyze the sound, and you can take decisions about your heart and lung conditions. So you can pass different types of data if you have a 5G network in a large amount of data, and that can be very helpful in the 5G. So 5G based IoT network and 5G cloud centric IoT network for medical applications are a big area of research at the present point of time. The other important aspect is that this particular type of data is time series data. Most of them, I'm not telling all the data, but the data of the body signals, mainly the ECG, EEG, your blood flow, right? All these are actually time series data, which means that it is a dynamicity. So in different time windows, the data are different, right? And this is very, very good indication of the disease condition or the health condition of a patient. So might not be that if you just try to understand the difference. If you are just trying to record a data at a particular instance of time, right, you might not get the disease scenario. But if you take the data for a large instance of time and you compare the data with a healthy individual, you might find some anomalies in the data. And those anomalies will predict, if you export those anomalies will predict the disease condition of the data, of the patient. And that's why time series data helps you. Okay, that's why you see that when you have a heart, that means when a doctor wants to have a thorough checkup of your heart condition, he or she advises you to go through a Holter test. So Holter test is a monitoring for a long hours. I think it is now for 2 or 3 days. It works out, right? So this particular Holter monitoring gives you the scope of a larger time series data, and you can just try to explore the sequence with the time window and whether the sequence is good or the sequence is bad, right? I'm not getting into details of this. There's a lot of type of variations. It can be univariate, which depends on only one parameter. It can be multivariate. The variation may be linear. The variation may be non-linear. The variation may be discrete, which is only taken with some interval. Suppose you take it every 5 hours. Okay, you take the data after an interval of 2 hours. But that's a discrete, but within a particular time boxes. Okay, and continuous. It's an entirely for the entire 24 hours or entire 48 hours. These are called continuous data. Okay. These are some of the important things you need to know, that how we analyze the time series data. So time series data is a little bit different analysis than the analysis what we normally do with the data which we have available in the form of features. So the data what I have shown in the previous examples, the data shown for the blood sugar level or blood pressure level or obesity or the fat. Okay, those are quantified data. Here the data is varying with time. So there are certain parameters. The way we define the parameters of time series that are a little bit different than what we have. Okay, so we have to see the trend. We have to see the seasonal variation, we have to see the cyclic variation, and we have to see the irregular variation. Okay. What are those? Trend is the mean variation. So we have a total variation over a large amount of time, as it's shown. This is not a medical data. This is just an example to make you understand what is the time series data, right? So this is a duration in time, and these are the values what we have, and so you take a mean of this, okay, over the entire time period, right? And this mean, okay, and this mean is actually the gives you the trend. Seasonal is something where within the intervals, within this interval of year, okay, if you find the variations, those are called seasonal. Cyclical is something where you actually find that something is repeating over maybe an interval is a bit larger, or is something repeating, right? And irregular is something random effects. So the 4 effects combines and tries to give you the time series. So when you try to analyze the time series, you have to try to predict that what are the, so try to generate YT, which is a function of TT, ST, CT, and IT. So what you need to do, we need to analyze individually TT, ST, CT, and IT. And you have to predict YT. So this is a little bit complex analysis, which you need to do. Okay, there are 2 ways we do it. We can either tell it's an additive model of time series, or it's a subtract, or it's a multiplicative model of time series. But it's a little bit difficult proposition. People also use the techniques like LSTM or RNN to understand this time series models. Okay. So now I will be ending up this. I will just trying to not discuss this on much depth. This is a very recent paper which is being published in Elsevier Biomedical Practice Journal by our group, which is the fastest and lightweight algorithm, most lightweight algorithm to date to detect the anomalies in your ECG. This is the anomaly in your ECG. And the difference between this is that it is not a time series model. It's based on a graph network model. So what we try to do here, again, I'm not discussing it on depth with liberation of time. We're trying to converge a biomedical signal using equivalent graphs. There are standard techniques, you can find it. And then what we have done, we have trained our network. It's a multi-layer perceptor network, having only a few neurons, okay, only 100 neurons. And that multi-layer perceptor network is being trained with the graph features of the normal as well as anomalous type of signals. And once we have trained it with this lightweight MLP based on the graph features, has worked very well and has outperformed all the best cases which are available. And this is one of the techniques which we are trying to now push. Instead of time series analysis, can we convert a time series data to a graph, and we can use the graph features to train our models and can predict from that. Okay, that's a new trend we have started, and this is a contribution from a collaboration with our group, University of Calcutta, okay, and IIT in Bangalore, and a startup in Bangalore. So this is being termed as a network approaches in anomaly detection for disease conditions. It's published in Elsevier Biomedical Signal Processing and Control. This journal gives you the 50 days download option. So if you search, you can still get the free download of the version. So if you're interested, please go and check the paper. Okay. So I end up the IoT for health. I will now squeeze around, okay, the 2 interesting topics which are also working. One is IoT for agriculture, which we are working with West Bengal Department of Science and Technology. Okay, this is a funded project which is given to us. Okay, so this is the stuff what we are doing. We are trying to use the visual sensors, and we're trying to reduce the use of pesticide and the fertilizers to prevent the pollution of soil and water. So we are trying to capture the leaf information through the visual IoT sensors, handheld sensors, or some sort of sensors which are planted strategically, or can be your also flying drones on your agricultural lands and agricultural field. And we are using some novel deep network strategies. We are just will be submitting our paper very soon into one of the top journals. And so this will try to categorize the exact pest condition and disease condition. And we are developing a very smart app based on that. So the farmer can just capture the image, press the app, and can get the information of the disease condition and the pest condition. So this is also a motivation, and a lot of research works are going on in this particular domain, which is called IoT-driven agriculture, right? And this is our smart app, right? We have taken at the first experiment, we have taken the Moong bean. Moong is one of the very, very economically high yielding or economically important crop in our country and many of the parts in Asia. So we have taken the Moong bean, and Moong is also heavily infested with these pest attacks. So it's important crop for us. We have taken, I think, 11 disease conditions of the Moong bean. We have taken their images, available images. We have a very good agricultural department in our university. They are helping us in doing that. So we are taking these are disease conditions. If you look into very carefully, these are the disease conditions and this is the pest condition. So we are detecting both the disease condition and the pest conditions of the leaf. And again, this is the app. This is the app what we are trying to deliver. Okay, at the government of West Bengal. Okay, so this is an app which will try to detect the disease and the pest condition of the plant. Okay. I'm not going into details of the deep network, but I will just tell that once the paper comes out, I will let you know. And this is actually also we are trying to build it very lightweight so that it can work on TensorFlow Lite, so that it can be installed on a very lightweight device. Last but not the least, okay, this is the work which we have recently started. This is the IoT for food security and food safety. This is the work which is a collaboration between the University of Calcutta, our group on IoT, and IoT and security, and the University of Florida. So we have already started this work. So this is actually how to track the food management. Okay, because there are two things. One is the food safety. Food safety means that whatever food you are offering, this food is good condition, not damaged, not stale, not adulterated. This is food safety. And what is food security? Food security is that you are trying to give food to all. It is not that food only flows to one pocket and doesn't flow to other pockets. Food should flow to all pockets. All the people in our country should actually get at least the balanced nutrients from the food. And whether we can track that, whether we can know that where is the nutrition deficiency, and accordingly we can supply the food to that particular sector of our country, of our state. That's the activity we are doing, and we are also trying to collaborate with the different government agencies on this activity. Okay, this is a snapshot. I will just tell what is going on in this activity. So this is food collection, food storage, food delivery. All are based on smart devices and data analytics. Okay, and there is a feedback system because in the real world, in the societal activity, if you don't keep the feedback system, you don't get the input from your mass, and that helps you to improve your activity and to actually know that whether your activity has actually done good or done bad. Okay, so this is the process we are trying to do, and many research activities we are trying to find out. There is a AI and machine learning scope, how we predict the need of the food, which sector, which community, which particular district of my state, of my country is having the most food scarcity, which districts are very good in terms of availability of the food. What will happen if there is some sort of disaster, some sort of flood, or some sort of drought happens in a particular region? What will happen to the amount of food which goes down due to this reason? How will I generate the supplement of that? Okay, so these are some of the issues which we're trying to target. Okay, and there is a safety and security. There are a lot of ways it can be adulterated, it can go stale, and it can be okay. So stealing can happen. Okay, unwanted use of food can happen. So we need to have have some sort of technique, like we are trying to focus on blockchain and other techniques, so that we can make sure that this particular food is a safe, right? And also we are trying to focus on livestock, how we can do the livestock management. If the livestock is one of the sources of the food, okay, they gives us milk, they gives us a lot of animal outcomes like eggs and all this. So can we try to focus on their development, livestock development, and try to make a technology aware development and supportive development, so that the farmers can produce them at best. Okay, this is already a work is going on in University of Florida and UC Davis, and we are getting a part of that activity also. Okay, so that's all from my end, and I close here because I think that I have extended my time limit, but I hope that I have tried to touch upon some very interesting aspects of my of the lecture, and so I go back to all of you to if you have any questions.
Thank you, sir. Thank you for your informative session. Sir, I think that the questions which were already written in the chat box that you have already addressed.
Yeah.
So now I would like to request our participants that if you have any more question, then you can ask me. Sir has also told you that if you have any question, you can ask me. So the platform is yours.
Okay.
So you can ask the question.
Debabrata Sharkaria, you please put your question. Okay, so Debabrata needs to be unmuted, I think, right? Okay. Okay, so can I unmute?
Basically, Debabrata Sharkel, you can unmute yourself. Please unmute yourself and you can directly interact with the resource person.
Yeah, Debabrata, if you are listening, you can so you can unmute and you can put your question to me. Okay, so I think he has gone silent.
I think there is some technical issue or something.
Okay.
Like
Okay.
that.
You can also put it in the chat window if you want.
Yes, you can also put your questions in the chat box. If you are unable to unmute yourself, then you can put the question in the chat box also.
So if there are any more questions,
Sir, I don't think that there will be more questions for this session. So thank you, sir. Thank you, the participants also. I think that, sir, the informations which you gave us during this session, the participants will be highly benefited by your informations. So now I'd like to invite our coordinator, ma'am, Mrs. Vapita Roy, to felicitate our honorable resource person and to conclude technical session 1.
Thank you very much, sir, for this informative session. I think all the participants will get so much motivations and they will get some idea regarding the application of this IoT in different sectors, as you mentioned, the healthcare sector, then the agriculture. So I think it is too much and it is a very informative session for all of us. So thank you, sir. Organizing team member, please please share the memento.
Yeah, so thanks for this wonderful gesture.
Sir, this is the token, the small token of appreciation and our respect. So
Thanks.
thank you very much, sir.
Thanks. So all the participants.
I think
Yeah.
anyone is want to tell something? Okay.
So
Okay, sir.
like
Thank you.
the session it seems. Okay. Thank you all. And if you have any questions, you can either directly put into my mail, or you can communicate with the departmental head, ma'am, and I will be getting the questions, and obviously I will surely come back to you with answers. Okay, so thank you all, and thanks to everyone for organizing this, and I hope that that means all of us will stay fine and safe. Thank you all.
Yes, sir. Thank you, sir. Okay, participants, we will meet at 2:30 for the next sub session. So I will send the link again, but the link is same. Link will be remain same as I sent in the morning for the first session. So till then, I am ending the session. See you at 2:30 sharp. Thank you all.